Let's now look into number system and digital electronics. In digital electronics, the number system is used for representing the information. The number system has different bases and most common of them are the decimal, binary, octal and the hexadecimal. The base or the radix of the number system is the total number of digits used in the number system. Suppose if the number system representing the digit from 0 to 9, then the base of the system is 10. The types of number system. The different types of the number systems are decimal number system, binary number system, octal number system and the hexadecimal number system. So, first let us look into decimal number system. The number system having digits 0 to 9 is known as the decimal number system, because we can represent only 10 digits, that is 0 to 9. The base of the decimal number system is 10. The numerals used in denoting a number take different place values depending upon the position. Binary number systems. The modern computers do not process decimal numbers. They work with another number system known as the binary number system, which uses only 2 digits, that is 0 and 1. The base of the binary system is 2 because it has only 2 digits, that is 0 and 1. The digital electronic equipments are works on the binary number system and hence the decimal number system is converted into binary system. Octal number system. The base of a number system is equal to the number of digits, that is for decimal number system the base is 10, while for the binary system the base is 2. The octal system has the base of 8 as it uses 8 digits, that is from 0 to 7. All these digits from 0 to 7 have the same physical meaning as by the decimal symbols. The next digit in the octal number system is represented by 10, 11, which are equivalent to decimal digits 8 and 9 respectively. In the earlier days of the computing, octal number systems and octal numbering system was very popular for counting inputs and outputs too, because it works in counts of 8. Inputs and outputs were in counts of 8, that is a byte at a time. Just like the hexadecimal system, the octal number system provides a convenient way of converting large binary number systems into a smaller, compact and the smaller groups. Hexadecimal number system. Hexadecimal number system is commonly used in computer programming and the microprocessors. The hexadecimal number system has a base of 16 and hence it consists of the following 16 numbers of digits 0 to 9 and A to F. The size of the hexadecimal is much shorter than the binary number, which makes them easy to write and to remember. It requires only 4 bits to represent value of any digit. Hexadecimal numbers are indicated by the addition of either an 0x prefix or an H suffix. Hexadecimal number system is used to describe locations in the memory for every byte. These hexadecimal number systems are also easy to read and write than binary or decimal numbers for basically the computer professionals. The main advantage of using hexadecimal numbers is that it uses less memory to store more numbers. For an example, it stores 256 numbers in 2 digits, whereas decimal number stores 100 numbers in 2 digits. This number system is also used to represent computer memory addresses. It uses only 4 bits to represent any digit in binary and is easy to convert from hexadecimal to binary and vice versa. It is easier to handle input and output in the hexadecimal form. There is a wide number of advantages in data science field, artificial intelligence and machine learning.